Hello everyone. In this video I would like to show you how you can use Node-RED to easily retrieve data from an IO-Link master to process this data and to display it on a small dashboard. So for this test setup I have connected an optical sensor to the master. And this optical sensor has an integrated counter. So this means that whenever it is triggered, so when a switch signal is released, the internal counter value increases and you can read this out, for example, via the process data of the sensor. As already described in previous videos about the web service of the master, by using the URL of the master /ports.jsn, you can retrieve a JSON file which gives you all the information about the connected devices and sensors. In the first entry of this ports list, you can see that the optical sensor is connected. We will now use this web service of the master to retrieve data via Node-RED from the master and then to process them here. To access the web service, you first need an HTTP request node. You can simply drag it into the flow editor, and with a double click you can edit the settings of the node. The method we have to leave on get, because we want to get data from the web service. We just need to enter the URL, which is the corresponding URL. So in our case it was http ://192.168.0.20, so the IP address of the master, /ports.jsn. Next, what to do is to change the return property because we want to get directly a JSON object back. So that's it actually. So next we need a trigger to execute this function and a display functionality to show the results afterwards. As a trigger, we can use an inject node. With this inject node, you can, if it's deployed, trigger a message by clicking on its small button, and then a message flows along the connection which you can place between the single nodes and starts the corresponding function on the next node. To display the result of this node, we can use a debug node. So every message that arrives on this debug node is going to be displayed on the right-hand side on the debug tab. Now we try that out by deploying it here and clicking on the mentioned button at the inject node. As you can see, you have now retrieved a new message here on the right-hand side. And this message contains the interface property and the ports property. And as we have already seen earlier, these are the properties of the web service of the master. So you can find behind the ports property a list with 16 entries. The biggest master has 16 entries and therefore 16 entries. And here at port 0, we have our connected sensor and we can find all data which is provided by the web service. Now the connection of to the IO-Link master is established, and we have actually called our web service and integrated the data here into Node-RED. Next, we can use Node-RED to process the data and then to display them on a small dashboard. To do so, we first have to filter the data by using a function node. You can drag it into the flow editor, connect the whole thing to my request node, and that means that the answer that arrives here can be added there. And with a double click, you can edit the function node itself. So the function node has a special feature here in Node-RED because you can actually program JavaScript. And so you can program relatively flexible functions. So first, give the function a name. And next, we can change the outbounding message respectively to the property payload of the inbounding message. So that means that actually we want to have the property of the output only to be the payload.ports, and from that is the entry 0. So this means that if we look at our message here on the right hand side, message.payload as our base message, and next the object number 0. So that means if we deploy this, you can delete the log files here actually. And if you add a new debug node here, then on this point, only the data from port 0 should arrive. As you can see here, the upper message is the first debug, and the second message contains only the data of the port number 0. So now we can select only the product ID, for example. So you can do this by jumping back in the function and then adjust here .product ID. After that, only the product ID is selected. Hit deploy, delete the log to get a better overview, test it, and then you see that the product ID is shown here. Now you can copy this function and insert it again, connect it again, so that the message gets multiplied. You can edit this one again, and we don't want to get a product ID here, but we want to have the process inputs, for example. Then again, deploy, delete, and test it. Of course, we have not connected the debug, so we have to do that first. Deploy, test it, and as you can see, now we are getting our product here in the first and the hex string containing the process data on the second debug node. The product ID can already be used, so that's a finished value. Our process data we can still process to a decimal value. To do so, we have to take a look into the operating manual of the sensor, and under the point process data, we can see how they are built up. Because we want to have the counter value, byte 0 and 1 are interesting for us. Back in our Node-RED program, that means that we only need the first 2 bytes of our hex string. That means only the first 2 and the second 2 signs. These together build the counter value. To extract those bytes from the string, we need a function node again. This function node can be placed here again. Then we have to connect it to the output of the process data here, and we can open the function with a double click again. First, we are going to create a temporary variable in order to make it a little bit easier. A variable can be created with the function var, and you can name it as you like. Next, we assign to the variable the individual parts of the string. So that means that the variable itself is afterwards message.payload. So that means the string that we bring into that node is going to be the variable. Then we use the function .substring. Then we can specify in brackets from which position we want to cut off the string. So we want to cut the string off from position 0 and cut the next 2 signs. Now we also want to have the next 2 signs additionally. That means we now make a plus and repeat it again. Message.payload.substring, and in brackets from position 3 again the next 2 signs. So now we have added both together. Now we do not want to have our values in a hex value, but rather we want it as an integer, so as a decimal value. This means that our output message, so the message.payload, equals, and then we need a function to convert the value from hex to dec, and this function is called parseInt. And then in brackets the variable we want to convert, so in our case it would be tmp, and then separated by a comma the base on which we want to convert into a decimal number. So hex has the base 16, so we have to add comma 16. So that's it actually. We can click now on Done. To get something displayed, we can drag a debug node and have to connect it again. Deploy, delete again, and test it. And now, as you can see here, we get at the very beginning our data, the product ID, the process data as a hex string, and now we have the process data here also as a variable as a decimal value. So we can simply check by triggering the sensor here a few times. And by clicking on the timestamp here, you can see that the counter value increased accordingly. So now we have the counter value already as a real value respectively to a decimal value. Now we can use this value to represent it on a chart, for example, or another type of diagram. To do this in Node-RED, you can use the dashboard nodes, for example. To use the dashboard nodes, you have to install them first. The installation can be found via the menu button and then Manage Palette. Via Install, you can search the online library of Node-RED. Here you can find many different prefabricated nodes to many different connectors. For instance, if you want to connect an SQL database or you want to connect a cloud service like MindSphere or something else, you can find this one here. In this way, you can also find the dashboard nodes by simply entering dashboard. Then you find node -red -dashboard, which would be the official Node-RED dashboard. And just by clicking install, you can install this function library. That's already something I have done. So you can find the nodes in the function library on the left-hand side. And as you can see, I have already installed many different other functions. And here you can also find the dashboard functions here. So now we can, for example, put a text on the dashboard. And as a text, we want, for example, our product ID. To do so, I just have to connect this output here with this text node again. Double click on the text, and then I can edit it a little bit. So first I have to assign the button, or at least in this case the text field, to a specific group on the dashboard. To do so, I have to create a new group via the little edit button. And a group will always be displayed on a tab or a submenu. And I still have not created one yet, and that means we have to do this one once first as well. So this means I can create a new tab. We name this one tutorial. And then I can assign the group the name sensor data, for example. Then I can make it a little bit wider so that we can see a little bit more of the graph later. I can click on Add. So now we have a new group called sensor data, which can be found under the UI tab tutorial. And we name the whole thing product ID. And which value is going to be displayed here is the message.payload, so the message that comes into this node. To make it a little bit nicer, we can push this a little bit more to the right, and then I'm already done here. So next I can create a graph, for example, for our counter. So for this purpose, you just need this chart node, attach it to our decimal output, and then on a double click you can edit this node. So here we already automatically selected the group which we assigned earlier, and we just keep this one for this one here. Click on done, and then we are done. We can deploy this and call up our UI. So how to call up the UI? Just hit in the IP address of the Node-RED, or of the device running Node-RED, /UI. And then you can see we have here our UI up and running. We have the group sensor data, where we should find the product ID and the chart. Unfortunately, we don't see anything because we haven't sent a message to the UI yet. So we just go back. And now we can either click here on this one here, or we would like to fill the graph, so I want to make it more on an automatic refresh. So click on the inject, click on repeat interval, and we want to have it every second. I would not recommend to do it fast than every second, because otherwise the web services master cannot keep up with it. So then again, done, deploy. And then I can also switch back in the debug tab. You can already see that the data gets called up every second. And if we now switch back to the UI, you can see that the data is displayed here. For example, the product ID on the top, and down here you can see the process value. And now, if I just change the process value by triggering the sensor, you can see that the counter value is increasing. So if I unplug the sensor, you see the value decreases to 0, and the product ID actually disappears. If I connect the sensor again, the product ID will be recognized again, and you see that the counter value is being reset to 0. So if I'm going to trigger the sensor again, you can see that the value is increasing. So that was it about the video about our Node-RED and creating a dashboard. So in just a few minutes, we created a dashboard and connected a sensor, processed the data, and displayed it on a web UI. I am free to do what I want with the data afterwards. So of course, I can display it on a dashboard. I can connect it to a database or an Influx database. You can connect it to a Grafana dashboard, send the data to a cloud. So Node-RED delivers many connectors, and no matter whether you want to use MQTT, OPC URI, or other connectors, so just try it out. So have fun testing, and thank you for listening. Bye bye.